Hello, welcome. I know it's midterm season, so I'm glad you guys took the time to come here. Today we'll be learning about recurrent neural networks. Um, so why is that important? Why am I teaching you this? It's because this is one step in a couple series of steps to get to from long short-term memory to transformers, which is what ChatGPT uses. So this is one step into getting into the cutting edge knowledge, right? So pay attention. This is what you guys learned for the last 3 weeks. Neural networks. You guys know there's the neurons, there's the input and the output, there's the layers, there's the hidden layers. You guys all know this stuff. And this is a normal neuron. That's one of those circles in the previous slide. There's the input vector, which has different features, x1, x2, x3. It has weights. This can be any number, but the weights match the inputs. And then there's a summation. There's the nonlinear activation function, and there's a bias that I didn't put here, and then that's the output. Is that clear to everyone? Okay. So here's the thing about neural networks. This input size is fixed, right? So if there's two input neurons, then you can only have an input length of 2, right? If you have something longer, you're going to have to somehow make that smaller or train a different model, right? So considering that, let's move on to something different, something that you guys haven't seen before, which is sequential data. Okay. This means that the data has an aspect of time. So that's why it's also called time series data. So think anything that's collected over time, right? A common example of this is like the stock market. So I gave a big hint in the previous slide, but I'm going to ask this. This data, right? Let's just say it's like the stock market, right? And you started collecting data, and one of them you started collecting 10 days ago, but another you started collecting 5 days ago. Could you train a neural network so that you could put both of these datas into the same neural network if you're just using a basic one? I'm seeing a head shake. Yeah, so no, yeah, correct. So yeah, that's correct. You can't because it's a fixed input length. So what researchers have to do is come up with a way to make a model that can take varying sequences of length, right? So just emphasizing the difference here, we're going to be talking about sequential data versus static data. Static data is what you guys learned about before, such as images, just data that doesn't have any point of time. This could be housing prices, where you're just trying to predict a single housing price based off of features that has nothing to do with over time. Or in this case, pictures of clothes, pictures of numbers, those are all static, right? But in this case, because we have time, right, this is sequential, right? And why is that important? Because time can be a factor that we should be accounting for, right? We maybe want our model to know that this is a time-based data, right? Because, for example, in the stock market, if you see that number going up for a couple of days, you might think it's going to keep going up, right? So you might want to invest, like thinking as a human. So you kind of want your model to be able to think like that. You want your model to be able to take into account previous data and know that comes from a previous time, right? So that's what we want our model to do. However, sequential data is like a lot more data, right? So if you only had a single day of data versus 100 days of data, that's a lot of data, right? Additionally, you can have different granularities. So 100 days versus collecting every hour of data for those 100 days versus collecting every minute, that's like way more, exponentially more. So there's a fine balance, and like if you have data that's too granular, you might have to like downsample to make it less granular and then make it into a model that you can like actually run on whatever hardware you have. So but obviously, state of art, they just get the whole entire sequence and then put it in because they have money. unless you're DeepSeek. I don't know. So here's some examples: stock prices, weather prices, rainfall. Heart rate. That's something that happens over time. Maybe you want to predict heart rate, try to detect some kind of heart disease. Um, One project I was working on, we were trying to predict Parkinson's disease by using brain spikes. So you might want to be predicting your sales. Like, is your sales going up? Is it going down? These are all very useful types of data we want to predict, right? And obviously, um, stock market, it's really unpredictable. And this is not financial advice. So obviously, people be using the most advanced AI to predict stocks because that's where the money is. So I won't be saying, oh, you get an RNN, you now know everything about the stock market. But I'm just saying this is a good way to start learning how these machine learning models work. So yeah. So we learned that we can't use this. So what do? Right? What I'm going to do is this is the normal neuron, right? And I've taken away the summation sign, I've taken away the bias just to make it more brevity and make it so because I'm going to put a bunch of other stuff on here. So does everyone understand what this is? Any questions? So there's the input, you multiply that by the weight, nonlinear, there's the bias that isn't here, and then that's the output, right? Sounds good. So what we're going to do here is we want an aspect of the previous time step, right? We want an aspect of the history. So what we do is we kind of store that activation, that weighted sum, and we feed it back into the neuron at the next time step. That way, the output is a factor of the input and that activation at the previous time step, right? So you have the X multiplied by the W plus, this is the WX for the weights for the input, plus the hidden state, which is that activation at the previous time step, times WH, and you add those together. So it's a factor of both. And then you have another additional weight that kind of controls how much of that we want for the output, right? So there's 3 weights here. That's 2 more than the previous model. Any questions? Okay. Here's the math for it. If you guys want to look more closely at the math, I know some people need the math to visualize it better. So what we have here is just W times H. That's, as I said, the weights for the hidden state times the hidden state of the previous time step, which is T minus 1, plus WX, which is for the input times the input at the current time step, plus bias. And you put that all into your nonlinear, like ReLU or sigmoid or tanh, and then you get your output. So that's great. So if this math is kind of hard to understand, as long as you understand what the graph is doing or the visual is doing, you actually understand the math. What we're going to do here is there's a way to kind of better visualize this, and it's going to be used in all types of sequential models, not just RNNs, LSTMs, etc. But it's called unrolling. So instead of just looking at this graph and putting the circle, we're going to put it out time step by time step. And what I've done here is I've taken that horizontal neuron and put it vertical. So on the bottom, here's the input, and on the top, here's the output. So this is an unrolled graph that would take in 2 length series of data, right? So X0 would be the first time step of data, and X1 would be the next time step of data. And this produces 2 outputs, right? Y0, which is the first output at the first time step, and then Y1, which is the second output at the next time step, right? And you're multiplying by WX, you're multiplying by WY after you get the hidden state. And to get the hidden state at the next time step, you're getting that previous hidden state times WH plus WX times X, right? And then you can just keep going, right? So that's 3 length sequence of data. And then you can even get n-length sequence of data, right? So this kind of is great because it kind of solves our problem that we had with normal neural networks, which is we couldn't put in varying length sequences of data, right? So now we've solved our problem. We've come up with something that tackles the issue we wanted, and this is what we have now. And then we're going to build upon that for the next coming weeks. And one thing to notice here is that it may seem like there's a lot of weights going on here, but it's actually the same three weights for every calculation at every time step after in the forward pass, right? So, yeah. So you might be a little bit confused. I talked about multiple outputs, and there's different ways to kind of interpret this output into a loss to make a prediction. So one of the most common ways is just to do a sequence to value, which means we just take the outputs at the last time step, and that's our prediction, right? And we just ignore all the outputs before it and just use that time step and be like, okay, I want to know what the weather is tomorrow. And I'm going to just put in all the data from the past days, and then I'm going to get that prediction for tomorrow. And that's what I want, right? And another way is sequence to sequence. So that's you compare the output at every time step to the data, and then you calculate your loss. And that's if you have some kind of inputs and you want every prediction at every day or every time step. And this is useful for if you're trying to analyze like sentences and want to classify every word in a sentence, or just want to like match it to a line, trying to like get a line fitted to another line. Any questions about this, or is this clear? Good stuff. Good stuff. Okay. So I'm gonna test your knowledge. You guys seem to know a lot, and I'm gonna give you guys a problem, give you guys 5 minutes to solve it. Here's the setup, Wx equals 0.5, Wy equals 0.9, Wh equals 1.1. We're gonna use the Rayleigh activation function. T starts at 0, so the last time step is 4. And then if we put in just 1, 2, 3, 4, 5 for our time series data, what would the output at our final time step Y be? So I'll give you guys 5 minutes, try to solve this, work it out. If you have any questions, feel free to ask me.